Okay, so welcome to the second lecture. So today I will explain to you a bit more theory about OpenNebula and how OpenNebula works, and by extension how most cloud solutions actually work. And we will also have a look at the lab sheet for the installation of OpenNebula itself onto our systems, which is what you should be doing next week when you come into the lab. So the idea behind OpenNebula is that it's a cloud solution. Essentially, it's a piece of software that runs on a server or on an assortment of servers and looks after your cloud installation, your cloud system. Essentially, there is a certain architecture to it. There is this basically, and what this means is these are all of the various components that are required for your cloud to run correctly. Now, in these components, the first one and possibly the most important one is the OpenNebula front end. So this is the software, the OpenNebula program itself, the 1D daemon, that runs and manages the cloud. Okay, so this will gather all of the information from the various systems that your cloud includes, and it will present them to the user, to the administrator basically, so that he can manage all of the resources available in the cloud. So when we're talking about resources in the cloud, the first and foremost resource that we need is the virtual machines. Essentially, we will have one or more servers that will be our hosts servers. They are powerful servers with lots of CPU cores and RAM that can run virtual machines inside them. So when we're talking about resources, the first two most important resources are CPU cores and RAM memory. Now, all of this as a virtual machine inside the cloud needs also to have some access to some hard drive space so that you can basically store or process any of the information that your cloud will need to process. That storage is contained in the data stores, so they will be in a separate storage area network server somewhere on your network. They will communicate with each other, those three components, with what we call the service network. So all of these devices, all of these servers will be connected with them, between them, with an internal network, which we call the service network. And on top of that service network, we also have the VM networks. So we have the network infrastructure required for all of the virtual machines that are running in the hosts to be able to communicate to each other if necessary and to the rest of the world outside the cloud itself. So the important components are the servers that can run the hypervisors on them, so that can run the hosts on them. We have the storage, and we have the networking in place, and we have the server that actually does all of the monitoring and processing of the information that has to do with the cloud itself, which is the OpenNebula front end. So, if we look at this, as I said, we can have different number of CPU cores, amount of memory, hard drive space, and so on. So all of this depends on the physical hardware that we will have available for our cloud deployment. Now, when we're talking about physical hardware, we're talking about CPUs, and we're talking about how many CPU cores each of these has, and we're talking about how many virtual CPU cores each of these can actually provide to the cloud itself. You can then move on from that onto how many virtual CPU cores each of the virtual machines that you are running in the cloud will actually need. Now, when we're talking about dimensioning the cloud, we're talking about allocating the correct amount of resources, so the correct amounts of CPU cores, memory, network connections, network bandwidth, and hard drive space for each of the VMs that we're running in the cloud, or each of the services that the cloud itself is providing to the outside world. Okay, because don't forget, the whole purpose of existence of the system is to provide with your customers some specific service. Okay, so for example, if you're Apple and you have your Apple Cloud, then one of the services that you're providing is that you're letting all of your users back up all of their photos and everything onto that cloud. Yeah, so first you need to provide them with some storage space, which they give you some for free and then you have to pay for the rest, right? Or you also need to provide them with the network connectivity between yourself your phone, your computer, whatever, and the cloud itself, so that you can actually get that information, get those photos over there and store them and back them up. Okay, so when we're talking about dimension of the cloud, we're talking about how many CPUs and how many virtual CPUs the cloud can make available to the virtual machines that run inside it, how much memory each of the virtual machines can have, how much hard drive space each of the machines can have, and how many network connections and how much bandwidth each of these virtual machines running in the cloud can actually have available to use so that it can run and provide the service to the user. So, out of all of these, there is an OpenNebula front end that has some minimum requirements. So the software that manages everything has some minimum requirements. So the host that will run everything will need to have at least 2 gigabytes of RAM, will need to have at least one CPU with preferably two virtual CPU cores inside it, at least 100 gigabytes of storage, and 2 network cards, one that will connect it to the service network that will connect to everything else, and one that will connect it to the outside world. The maximum number of servers that you can have, virtualization hosts and so on, it all pretty much depends on the hardware that you have available on your cloud. Okay, so it can get pretty big. Generally, in order to make it easy to manage, you can get about a maximum of about 1,000 servers in each of the virtual data centers that you create inside the cloud. If you split them to more virtual data centers, so if you have more zones, you can have essentially infinite servers, as long as your front-end server is powerful enough to manage all of this. Okay, so you can make as big a data center as you like and as big a cloud as you like, as long as you give the OpenNebula front-end enough processing power to basically be able to monitor everything in real time and process all of the information. So, how do we run our virtual machines? We run our virtual machines on the host that is enabled for virtualization, that has our hypervisor in place. The preferred hypervisor for OpenNebula itself is KVM, which is a Linux Red Hat Navy virtualization hypervisor. And out of that one, we can have CPU cores, we have the memory that we allocate to them, and so on. So all of the dimensions of all of that are explained here. I won't go into details, You can have up to 80 CPU cores, whatever per VM, we don't really care that much about it at this point. What we do care about is how the storage actually works. So when you have a virtual machine running in the cloud in OpenNebula, the image of that virtual machine is essentially a hard drive that is stored somewhere onto the image data store. So there are 3 basic data stores for OpenNebula. There's the image, the system, and the file. The file data store is self-explanatory. You can store files onto it for general use. The image data store is where you store the images for the virtual machines that you have built and configured for your cloud. And the system data store is the place where those images are copied to when they're running. Okay, so when you instantiate, as we call this, a virtual machine inside the cloud, when we start it and let it run, the image of that virtual machine is copied onto a different data store, onto the system data store, and it runs from there. We do this for safety purposes. Okay, so your virtual machine might get corrupted, some data might get corrupted onto it, and so on. You will have an immediate backup of it running onto the image data store itself. Also, this gives us flexibility with regards to what we're actually doing with those images, because let's say, for example, that you are a company and you have lots of users that work remotely from home. However, you want them all to connect remotely and work in your company's computers, and those company computers need to be configured all in the same way. So what you do is you build one template that contains whatever images you want for the virtual machine that each of the employees will connect to, and then you can start multiple instances of that image for all of the various employees that connect onto it and work. This way, you don't need to build one computer or even one virtual machine per user. You can build one. It will look the same for everybody, and everybody can log in using that one, or rather using multiple copies of that image, of that virtual machine. You don't need to do anything about it. You can say, I allow this image to be instantiated 100 times, so 100 employees can concurrently connect onto my cloud and work. All of their personal files and personal information can be stored into the file data store, so in a separate hard drive on your cloud. And then once they log in, they get access to that information, and they all have their own wallpapers, desktop settings, and personalized files. And you don't need to do anything about all of this process other than the initial setup of setting up the image and telling the system that it can run it at 100 times. Okay, so it makes life easier for the company, for the administrators. It makes it, of course, when it makes the life easier for an administrator, it means that you're saving money because you're not wasting employee time on managing and maintaining the system. Okay, so that's what those two data stores actually do. Network itself, networking can get extremely complicated in a cloud environment, essentially. So the important aspect of it is that you need to have what's happening. All right, you need to have your service network that connects all of the components of the cloud between them, and then you also need to have the network that connects the virtual machines between them or to the outside world. Okay. Of course, it's database driven. We are using SQL for this. For your particular deployment, you won't need to worry about the database aspect of it because all of the components of the architecture are being built onto one computer. Okay, but generally it is SQL based. Monitoring happens with the 1D daemon that runs on the front end, so it monitors all of the available resources that are running at any given time. So on your web browser, on your web interface, or even in terminal mode if you want to, you can get information about how many of those virtual machines are running, how many CPU cores they're using, how much memory they're consuming, how much hard drive space they need, how much networking bandwidth, how many users are connected onto them, how many instances of virtual machines are instantiated, and so on and so forth. The virtualization hosts are essentially the biggest part of the cloud itself. Because yes, you will have one storage server somewhere that has all of the data stores. You will have one server for the front end. You will have some switches for the networking. But the biggest component of the cloud will be the virtualization host, will be the servers that can run multiple virtual machines onto them. And they need to be the strongest ones. The more CPU cores you can have and the more memory available that you can have, then the better that will be for your cloud itself. Storage itself can be directly attached onto the host through the service network, and it can be on a storage server itself separately. In some smaller deployments, you can actually use the data stores locally on the deployment servers themselves. Of course, this has the drawback that if one of those virtualization hosts goes down, then you will lose the storage allocated to that one as well. So if you do run it like that, you need to make sure that any of the virtual machines that are running on that specific host, they have their own storage space allocated onto them, so that if the server goes down, you only lose the VMs that are supposed to be running on that server. Okay. It's not recommended, but for smaller, cheaper deployments, then you can do this as well. As we said, the three types of data stores that are available. Networking, you need at least two different physical networks available for your cloud. So you will need your service network and you will need your instance network as well. So as I said, the service network is what connects all of the devices between them, the hosts with the storage server and with the front end. And you can also have an instance network, or rather you should have an instance network, which connects the VMs between them and gives the VMs access to the outside world. When we build this onto our systems, we will have the service network available straight away because everything will be built onto the same computer. So the service network for us will essentially be the 127.0.0.1 address, and that's it. and then we will configure in the second to last lab sheet our networking for our instance network, and that will be configured through OVS, so that's Open vSwitch, and that is the most complicated network way that you can do networking in OpenNebula, but you can do absolutely everything you want on it. So it is the most flexible and the best way to go about it. Authentication methods available are various onto it. The most important one is the SSH authentication, because that is what is actually used by the front end in order to log into all of the hosts and monitor what they're doing. And one of the important aspects of the installation of OpenNebula, as we'll see later on, is setting up the passwordless SSH communication between them, and we'll see how that happens. And there are other components as well to it, which I will not go here because we won't really cover them in the lecture as well, in this module, but you can look them up and see what they actually do if you want to. Okay, so I know we all hate the theory, but what can we do? So let's put this into practice, yeah? So OpenNebula installation. The idea is that you will each set up your computers as a cloud. And more ironically than that, you will each set up your virtual machines as a cloud. So the virtual machines that you will be building today in the labs, they will have 8 cores and 32 gigabytes of memory and 400 gigabytes of space for the single purpose that they can run a cloud inside of them on their own. Okay. And that cloud will be able in turn to start up other virtual machines, at least 4 by the time you reach the end of the semester. Okay, and they should all be able to run easily and without delays. So how do we do this? We need to set up our front end. So our Prometheus virtual machine will first of all become the front end for this. So we need to install OpenNebula itself onto it. So because OpenNebula is a piece of software that is privately developed, the system needs to know where to go and get the installation files for it. So we do this by creating a custom repo, a repository file, as we call it, which lives in etc. yum repos.d in OpenNebula.repo. All it is, it's a text file that you're creating that contains these lines here. So out of these lines, the most important one is, oh my god, I clicked on the link. The most important one is the link that explains basically where the installation files actually live. Okay, so once you create this file, then the operating system on Prometheus will actually know how to go and get all of the installation files on its own. All right, so what we need to do is we need to run yum-y install Apple release, so that will reread all of the repositories available in etc. yum.d repos. Okay, and then it will learn about OpenNebula being there. And then once you do this, you start installing all of the required packages one by one. So we need to install OpenNebula Server and OpenNebula Sandstone first. OpenNebula Server is the front end, and OpenNebula Sandstone is the web interface that manages the system. Okay, so you will need to have this. You need to install OpenNebula Server and OpenNebula Sandstone, which is the GUI essentially, the web interface for the server. You need to install the gate and the flow, which manage the communication between the virtual machines that your OpenNebula server will run. And you need to install in the end the OpenNebula node KVM, because this will now turn your host into the second component of the cloud. It will turn your host, your Prometheus VM, into a virtualization host. So going back and looking at that other diagram that we had before, you now have 2 of the components that you need. You have the front end and you have the virtualization hosts as well. Okay, because remember, we're setting all of these components up inside your virtual machine. So once you do this, the software will be installed. Together with the packages themselves, the system will install any dependencies required as well. Okay. And then you can basically sort out the next step, which is you change users. So you SQ as user 1 admin, which is the admin account for the cloud itself. And you set up, you type this command, echo 1 admin localhost 1 to 1 underscore auth. So this is setting up the password for the one admin account. Okay, so just like we set root and localhost 1 everywhere, we'll set the one admin account to be localhost 1 as well. What's important about this is that if you get this step wrong, and then you start your cloud, you won't be able to change your password afterwards. Okay, so make sure that you get this correctly. What I've done in this lab sheet is all of the commands that you need to type are on separate lines. Okay, I could have login as OpenNebula admin user and then just put su1 admin next to it, but I haven't, because now you can click on this and you can copy and paste them onto the terminal. All right, so the easiest way to go about the lab sheet is to actually copy the commands from here instead of typing them and paste them straight into the terminal. And the best way for you to be able to do this is to actually have the lab sheet open inside Prometheus. So ideally what I want you to do when you come into the lab is log in as VM8 or VM9, start your Prometheus app and full screen it, and at the end of the first lab sheet I ask you to install Google Chrome. The reason why I do this is so that you can actually use Google Chrome inside your virtual machine, so you can get your logbook running in there, because the logbook is a Google Doc, so you need to have compatibility. Yes, you can use Firefox, but sometimes the images don't copy correctly and they're not saved correctly on the Google Doc in Firefox. Thank you, Google. So, if you get Google Chrome running inside Prometheus, which is on full screen, and you have the lab sheet open in there as well, and you have a terminal open next to it, is the easiest way to copy and paste the commands from the lab sheet into the terminal, hit enter, and then take screenshots of them and stick them in the logbook straight away. Okay, so it's the most efficient way to go about it, basically. So that's why the commands are all on different lines. So once we set up the password for user1admin, we then exit from the user1admin, and then we need to go and find the file sunstoneserver.conf. So we edit that file, we go to the very end, and we find those two lines and we put a hashtag in front of them. This will comment out the FireEdge interface. The FireEdge interface is another management interface for the cloud itself, but we will not use it, not for what we want to do anyway on this course. Okay, so it's best that we disable it, because if we left it on, it requires some other components to be installed as well, so then it adds complexity and we don't really need it. Okay, we will manage everything through the Sunstone web interface for this. And then, so once you set up the password and once you've disabled the FireEdge interface, then we can basically service OpenNebula restart, so that will start the OpenNebula service. I personally always do restart because I don't know if a service is running or not. Okay, and then check config OpenNebula on will set the OpenNebula service to run automatically every time you start up your Prometheus server. Same goes with OpenNebula Sunstone as well, the web interface. Restart and set it to on, and then finally we need to restart the libvirt service. This is the software on your operating system that manages any virtual machines that are running onto the system, and it handles the KVM virtual machines as well that you will use later on. Once you do all this, you can run one user show, and then this command should show you that there is one user. It has a user ID of 0, it's called one admin, it has a home directory or whatever, and some other information that you don't really care about. Okay, but if you get a valid reply from this, it means that you've installed OpenNebula front end correctly, and it works. Once you do this, the next step is to configure passwordless SSH, as I mentioned in the authentication stage in the previous document. So we need to make sure that our OpenNebula can communicate with our virtual machines and all of the other components in the cloud without any input from us. So basically we need to set up passwordless SSH between our front end and everybody else. So you switch to one admin again, and you edit the configuration file .ssh config. You edit it using the VI editor, because that's a text editor that runs in a terminal, because you have SU'd into one admin, so it will not let you start any graphics related program on the operating system. Okay, so you cannot do gedit.ssh config. All right. So you use VI, and I've tried to help you figure out how to use it on this. Yeah. So out of the file that comes up, there's a line that says host and then an asterisk. You need to change this, the strict host key checking, from yes to no. So this basically means that every time somebody tries to log in, the client itself will not try to check the key of that host and see if it's the same or not. And you need to add this line, because this line will not exist at all inside that file. You need to add user known host file dev null, essentially telling the system that there is no user known hosts file for you to check, so you can just go ahead and log the user in without asking for any password. Now once you're here and once you've made the changes, you can save and exit the file. So you need the :write quit. Okay. And then you need to change the permissions of this file to chmod 600, and then you can basically give it a try, and you can type SSH localhost. So try to SSH into the computer that you already are, as the user that you already are, and it should just do it and not ask you for a password or anything else. Also, you need to do it once before you try to actually use the cloud itself, because it needs to happen once manually. You need to SSH once manually, so that the system, so that the SSH software itself knows that it's using passwordless SSH, and once it's done it once, it keeps it in cache memory and it stays like that forever. Well, until you change it. So now that you've done this, you can actually go onto your browser. You can click on this address on the LabSit itself, which of course, if the LabSit is running inside the virtual machine, it will open on the browser inside the virtual machine. Okay. And then the Sunstone interface should start up and you should be able to see your dashboard. Of course, you'll have to log in as one admin, password localhost 1. When you do log in, if the system asks you if you want to save the password, please save it. Okay. It will save you lots of keystrokes and clicking in the future, because you log into this hundreds of times. All right. So save the username and password and let it log in automatically in the future. And that's it. The rest of the LabSit, there are the couple of pages that follow this, are essentially useful information that you need to know, or you might need to know at some point when you're working in OpenNebula. So there is directory structure, so where everything is located, so the configuration files and etc. one, the log files which are important are in var log1, and so on and so forth. And finally, in the end, if we ever have any problems with the firewall itself, then the ports that everything is running on are available, listed here. You don't need to do anything about the information that's on the tables in here. The LabSit for you, the things that you actually have to do on your system, stop to the point where you log into the web interface and you can see your dashboard. Okay, so idea for the next LabSit is, after you've built your Linux box, you essentially install OpenNebula, so that you can move on to the next LabSit, which is, we'll build, I think it's a familiarization LabSit for OpenNebula itself. Okay. Any questions about all this? All right. So the most important thing to remember is that all of the components of the cloud we are building inside Prometheus itself. Okay. So our data stores will be the storage space that Prometheus provides, the 400 gigabytes in there. The CPU cores for all of the virtual machines that we're running through KVM are the 8 CPU cores and the 32 gigabytes of RAM that the virtual machine can provide to us. We don't need the service network because everything is on the computer itself, everything is on the same host, and our virtual machine network will build it later on the fourth LabSit with OVS. Okay, so this is a quick recap of how we're installing the system. All right? Yes?
So what you actually doing is that, when you come to clouds, you have the process of doing things like designing, provisioning, and deployment.
So that is relevant to bigger deployments. Essentially, what we will be doing in the lab is we will be we'll be creating a test environment where we can go in and try out all of the technologies and all of the features that this specific cloud can offer us. Building a cloud and dimensioning it and so on later on in real life requires a lot of preparation, because everything will not definitely be installed on the same host. So you will have your virtualization hosts, your hypervisor hosts where all of the virtual machines will run. So you need to decide, like if it's a big deployment, if it's a big data center, you need to decide which racks will hold the virtualization servers, and then where you will actually store your front end, and then where actually your storage servers will be. And then of course you need all of the switches to connect all of these between them, so that will be the service network. And then you will need to decide how you will get from that service network and all of those switches onto the outside world and provide the services to your cloud as well. And of course, you also need to think what the main business model is for the cloud. So what are you building the cloud for? Who is going to use it? What sort of usage do they need? Will they be light users that can do away with one CPU core, that can get a browser that gives them access to a company software that is web-based, and then they can just use it, log in, and then forget about it? Or will it be researchers that are doing something really difficult that requires lots of CPU cores, that will need lots of hardware space to create all of the data sets and files and everything else? So all of this, the idea behind the cloud itself starts with, what do you want to use it for? It's the same as everything else. You want to buy a car. What do you want to use this car for? You want to go racing, or you want to carry stuff around? You need a van, or you need a race car? So it all depends. It all starts with the top-down approach, as we call it. What is the business model for the cloud? And then from then on, you can decide all of the components that you will need in order to be able to provide this. Yeah? So you don't start with, I have a space that is 100 square meters, I can fit so many racks in it. You start with, I'm going to need to have so many users. This means I'm going to need to have so many CPU cores, this amount of RAM, and so much hard drive space. How can I host this? Then that will take you down to the servers that you need and all of the switching for networking and everything else. And then that will take you onto the physical dimensions and layout of the data center that we're building. And then you can actually go on and build it. Okay. Anything else?
So that depends on your needs.
Completely. Yeah, and don't forget, you can also have a cloud that can be used for multiple purposes. So for example, the big cloud providers out there, like Amazon for example, they have a bunch of servers everywhere scattered in data centers across the planet, and you can rent some data space or some cloud space from them. So when you rent some cloud space from them, they ask you, what do you need? How many CPU cores will you need? How much memory will you need? How much bandwidth in your networking? How much hard drive space, and so on. So they create what we call a virtual data center, so a little cloud just for you, that contains exactly the specification that you need for your job, for your purposes, and then you pay them for it accordingly, of course. Okay?
So that falls under IaaS.
Sorry?
So that's, as you mentioned, does it fall under IaaS?
Of course. Yes, of course. So ideally, what your job should be when you graduate, you should be the person that understands the business behind your company and can do the translation to resources needed. Yes? So you will have the management of the company saying, oh, I want to implement this cool new thing that I heard about. And you have to be the person that can tell them that, okay, this cool new thing that you heard about actually means that we need to pay X amount of money, because that's all they care about, yes, all the company cares about, every month, in order to rent or create some cloud space in a provider, or build our own, if it makes financial sense, okay, and use it every month, and that's it. All right, so this is where the big money is, essentially. If you just become a normal system administrator that just manages a few servers, then this is nothing. Like at best, you'll get to 100, 120K a year salary. Okay, but this should only be a starting point for you. Okay, you should try to think bigger than this. All right. So I'll stop recording here.